Okay, next problem here it is given. If V is going to be equals to x minus y plus xy plus 2z of volts, find the electric field intensity at the point of 1, 2, 3, and also we have to find what is the energy stored in the cube of a side of 2 meter center at the origin. This is what it is given for us. The first we know that our electric field intensity is going to be in terms of potential, that is minus del of V. That is nothing but I can write here. Observe here what is the coordinate system it is given. It is varying with respect to x, y, z only. Therefore our equation is going to be minus dou v divided by dou x into ax plus dou v divided by dou y into ay plus dou v divided by dou z into az. This is the basic equation we already know. Next, what you have to find? We have to find V is already given. From this, we have to find differentiate with respect to x, with respect to y, and with respect to the z. If I go with the differentiation with respect to x, then what you will be getting? Dou v divided by dou x. Here 1 you will get. Here it is not there, means it will be going off 0. Here again it is x y is there, right? You will be getting as a y only. You say y is a constant. The differentiation with respect to x is nothing but 1. Therefore 1 into x, y is going to be y only. Therefore 1 plus y in terms of dou v by dou y is going to be, here minus 1 is there, here plus x will come. Here z is no constant value, so it will be 0 only. Therefore minus 1 plus x, then dou v by dou z. If there is our z term is there in the last one only, where if I differentiate z means 1, 1 into 2, again it will be getting as a 2 only. Then substitute of dou v by dou x, dou v by dou y and dou v by dou z in the equation. Then you will be getting as E is going to be minus of 1 plus y into ax plus x minus 1 into ay plus 2 into az. This is what you will be getting. Next, at the point where what it is given for us, that is x, y, z. After getting even value equation, after differentiation, in this equation you have to substitute this as a x, y, and also with the z. X is 1, y is 2, and z is going to be equals to 3 only. Therefore E is going to be equals to what? Just you substitute here in this equation. You have to substitute for x, y, z. Then you will be getting an equation as A is going to be equals to minus 1 plus 2 into ax plus 1 minus 1 into ay plus 2 into az. That is going to be equals to minus 3 ax minus 2 az, that is volts per meter. This is what you got for the electric field intensity. Hoping you are getting right, you have to substitute here. That's it. Then use the equation WE, that is going to be equals to 1 by 2 with the volume integral F log naught times mod of E whole square into dV. This is the energy stored equation. Mod of E is what? This equation we already got E, right? This you have to square it, or else you can go with the finding of here, but better go for this equation only. Therefore 1 plus y whole square plus x minus 1 whole square plus 2 whole square. Then if I squaring it, the square root and squaring, it's going off. The remaining part is going to 1 plus 1 y whole square plus x minus 1 whole square plus 2 whole square. Then simplify the equation. Use your a plus b whole square equation. Then here also a minus b whole square equation. A small simplification is required here. After getting simplification, you will be getting as y square plus 2y plus x square minus 2x plus 2. Here it will be 4, here 1, here 1. Therefore it will going to be 6 only. This is the equation where our dv is nothing but for the Cartesian coordinate system, it is of dx, dy, dz. For different coordinate system, the dv will be changing. That in first module only it's finished. Okay, you should remember those equation. Then you have to substitute here. Then cube is centered at the origin. Therefore the values of x, y, z means the what its cube is of, it is centered at the origin. Observe here, it is cube of sides 2 meters centered at the origin. It is of a 2 meters, means each of the side, it is where it is varying, it is of a 2 meters means minus 1 to 1 means it will go, total value is going to be 2. For that reason minus 1 to plus 1 x, and also for the y minus 1 to plus 1, and also for the z is also minus 1 to plus 1. Therefore the equation is going to be we is going to be f long times, this is a constant value, so here it is written f long naught divided by 2 integration, z is varying from minus 1 to minus 1 to 1, y is also same and x is also same, and write the equation for e, where you got this equation here. Then dx dy dz. Then where I'm interested in changing the limit from minus 1 to plus 1, you can change, or else if you can go with the simple after simplification, you can substitute a limit, you will be getting the same. Here it's taken as changing from 0 to 1. You can do, or else you can skip off this of doing, or else normal integration if you do, you will be getting the same result. Okay, f long naught time divided by 2. When I'm changing the limit from minus 1 to minus 1 to 1 to the 0 to 1, here you have to multiply one integration, what it is changing, it's twicing of that time, it is multiply we have to do for the equation. For that reason 1 2 3 integrations where the limits are changing, for that reason 3 times we have to multiply the equation, 2 into 2 into 2, 3 times you have to go with. Then remaining equation written as it is. Then you go with the integration, simple, with respect to x you have to do, with respect to y you have to do, and with respect to z you have to do. Then you will be getting the equation as, after integration, the whole for f long naught x y cube divided by 3 plus z x y square plus x cube divided by 3 y z minus x square y z plus 6 x y z. Limit is going to varying from 0 to 1. When it is varying from 0 to 1, all the limits are in the same range. So just you will be getting as 1 by 3. Then here also 1, and here 1 by 3 minus 1 plus 6 you will get. When multiply with the 4 into 8.854 into 10 minus, then you will be getting equation as 0.2361 nanojoules. This is what the energy stored in the given parameter in the cube side of. This is one problem. The next problem here, point charges. Here different point charges are located in a different points. For them we have to find out what is the energy. Point charges Q1 is placed at 1 nanocoulombs and Q2 at minus 2 nanocoulombs and Q3 3 nanocoulombs and Q4 is of minus 4 nanocoulombs are placed one by one in the same order at what here the value are given as x, y, z all are in a origin where it is 0, then at 1 0 0, then 0 0 minus 1 and also 0 0 1 respectively. Calculate the energy in the system when all charges are placed. We have to do this problem. The simplified block diagram for this here it is given as, where our Q1 is located at the origin, so all are 0. Then Q2 at 1 0 0, x is at 1, Q2 x in this direction, x y z. Observe here in this direction it is taken. Therefore 1 0 0. Then about 0 0 minus 1 means here Q3 is located 0 0 minus 1. Then Q4 at 0 0 1 in the z plane. This is what the diagram it is going for. And what next? When Q1 is placed, this Q1 is placed, the work done is 0 because it is at the origin only. No, it's not requires any energy, so that the point charge should be moved from somewhere to the origin. That's why the work done is going to be 0. Therefore, electric field intensity is also going to be 0 only. When Q2 is placed, when I am going to pick up the Q2 and I am going to place in the coordinate system with the distance 1 0 0. The field of Q1 is going, already it is present. Then what is the W2? This how you have to write, it is in the theory part, it's already explained. Just once you go through, then it will be easy for you. W2 is going to be the point charge of that part, that is Q2, and V21, that point charge with respect to the 1 for that reason. Therefore, that is going to be equals to Q2. We know that V21 is going to be the point charge is of that part Q1 divided by 4 pi epsilon naught into R21. Whereas R21 is the distance between of these two is going to be equals to 1 only. R21. Yes, the distance from 0 to 1 only for that reason. Therefore, W2 is going to be substitute for Q2 minus 2. Then Q1 is of 1 divided by 4 pi into 8.8. 5 and 10 is to minus 12. R21 is 1. Just simplify this. You will be getting as minus 17.9754 joules. Then when Q3 is placed, after Q2 is placed, we are going to place with a Q3. When it is placed, there is field due to already 2 point charges are there, means the exhibiting with the Q1 and also with the Q2. Therefore, Q1 and Q2. Therefore, W3 is going to be equals to what? Observe here. Q3, V3 1 with respect to 1 and also Q3 with respect to the one more point charge Q2. Therefore, QV3 2. Therefore, the equation is going to be Q3 is same in the both case that you can take a common. Then Q1 divided by 4 pi epsilon naught R31. If you are confusing, if you are able to write this part, directly you can write here as a R31. Simple, right? Plus Q2 divided by 4 pi epsilon naught R32. What is our R31 from here to here? 3, 1 with respect to 3 to 1. What is the value here? It is 1 only, right? Then R32. Where is our 3 Coulomb point charge here and also at here? 3, 2. What is the value is going to be? Apply your point form equation. That then you will be getting as it is a equation value as that is going to be square root of 2. Whereas by Pythagoras theorem also it's you can take this if you consider as a triangle. Here it is 1, here it is also 1. Therefore, diagonal is going to be equals to square root of 2. Simple maths you can use here. Then we got the distance, then substitute in the equation, then simplify that, you will be getting as minus 11.168. This is up to where? Up to the third point charge is placed. Is one more left is a fourth point charge where it is exhibiting for all, remaining all. Therefore, Q2 is placed, there is a field due to Q1, Q2 and also with the Q3. Q1, Q2 and also with the Q3. Therefore, W4 is going to be Q4, V41, Q4, 42 and then 43. You should consider all the point charges when you are calculating for the last point charge where you are going to place in that field. Therefore, the equation is going to be Q4 you can write a common. Then the remaining is of Q1 divided by for with respect to 1, with respect to 2 and with respect to 3. Q1 divided by 4 pi epsilon naught R41 plus Q2 divided by 4 pi epsilon naught R42 plus Q3 divided by 4 pi epsilon naught R43. Then calculate for R42, R41 and R43 where you will be getting the values as R41 is going to be equals to 1, R42 is going to be square root of 2 and 43. Observe here. This is it's simple. You go what? 43 is of what? Here to here the distance is going to be 1 and again here to here it is of 1. It's not minus 1 plus 1. The total charge, total distance you have to take. 1 and 1, its total is going to be 2, right? Based on that you have to take. Plus 1 minus 1, it will be coming as 0. Don't consider of that. Total distance we want, that's it. Then substitute for the distances in the equation and also of the point charges. Then you will be getting as minus 39.035 joules. Then what you have to do? We have to add W1, W2, W3, W4. Then take all the values here. Then add of those. Then you will be getting as minus 68.178 joules. Like this problems, it will be asking for 6 marks. Okay. Next, the potential field in a free space, it is given by V is going to be equals to 50 divided by R, where R is in between of A and B. Observe here it is of a spherical coordinate system, we have to show that our rho v is going to be equals to 0 when our r is in between a and b. Next, find the energy stored in the region in between r, when it is placed r with the in between of a and d, it is asked for us. First, you have to find out what is the electric field intensity. Then rho v is going to be equals to, we know the equation as del dot of D, means flux density we want. First we have to find flux density, then we can show that it is whether it is going to be 0 or not. If I want the flux density, first you have to find out what is electric field intensity. For us here it is voltage is given already, that is potential it is given. From that we can find out the electric field intensity, right? Use the equation for the spherical coordinate system. Okay, that is E is going to be minus del of V, that is nothing but for the spherical coordinate system minus dou V divided by dou R into AR plus 1 by R dou V divided by dou T into A theta plus 1 by R sin theta dou V by dou pi of A pi. Then find out what is your dou V by dou R, dou V by dou theta and dou V by dou pi. If you observe here, it is only varying with respect to R, so you will be getting as dou V by dou R only, and remaining these two will be going to be 0 only. Therefore, when I differentiate the potential with respect to R, I will be getting as, this is 1 by R, 1 by R I can write as R raised to minus 1, right? The differentiation is going to be what? R raised to minus 2, right? Minus of minus 1, minus 2. And this minus you have to write here. Therefore, dou V by dou R is going to be 50 minus of 50 divided by R square. R is, you can write R is to minus 2, R is 1 by R square. It is okay. Therefore, we got the electric field intensity as 50 divided by R square into AR. Then the flux density is going to be what? Just multiply with the epsilon naught. That's it. Therefore, D is going to be flux density, that is going to be epsilon naught times E, that is 50 epsilon naught divided by R square into AR. Therefore, rho V is going to be del dot D, that is going to be 1 by R square. Observe here, again we are using for del dot D equation, that is going to be 1 by R square dou by dou R of R square into dr. Only with respect to R it is varying, and remaining part you can, it's not needed, you can write it directly as 0. Okay, or else if you write only of this much, you can tell that here it is varying with respect to R only. For that reason the remaining part is going to be 0. Okay, then substitute for our, what is our D we got in the previous case, that one 1 by R square dou by dou R of R square 50 epsilon naught divided by R square. This and this will cancel off, right? Dou V by dou R is not only there, therefore rho V is of what now? It will be 0 only. Hence, we proved that it is the first case, that is rho V is going to be equals to 0 when our R is in between of A and B. A and B is some of the limits where it is varying the radius, coulombs per meter square in terms of a rho V. This is what we proved the given equation. Then second one, WE is going to be 1 by 2 integration volume F naught times E. We already calculated what is our E, right? From this, take 50 divided by R square, that to square, right? If I want mod of that, right? Then that square root of this, again the square is going to be square root and square root cancel off. Remaining will be 50 square divided by R raised to 4 only. Same in the previous case, how we done with the distances, right? The same thing here it is done. Therefore, here the dV is going to be what? R square into sin theta dr d theta d pi. This you have to remember. Then where is our pi is varying? In general, in the problem it will not be given. You should know this. Where pi is varying from 360 degrees, therefore 0 to 2 pi. Theta is varying from 0 to pi, and in this case it is R is given for us. For that reason, R is varying from A to B, and write your E 50 square divided by R raised to 4 into R square sin theta dr d theta d pi. Then go for the integration. R square, here R square only remain with 50 square divided by r square remaining. Go with the integration, then you will be getting as, for sine you will be getting as minus cos. Theta is varying from 0 to pi, and pi here we don't have any pi, it is varying, only d pi is there, so it will be getting as pi, where limit is going to change from 0 to 2 pi. Then with respect to r, if I integrate, you will be getting as 1 by minus 1 by r, where the limit is a to b. Therefore, when you solve for this, you will be getting as 1250 f log naught 2 into 2 pi. Simple maths. You can apply the limit. You will be getting minus 1 by b minus of minus 1 by a. If I simplify here, you will be getting as 1.39 into 10 raised to minus 7 1 by a. First here it is written, minus of minus plus is going to be, then minus 1 by b, it's of in terms of a joules. This is how a problems you have to solve. Both the problems minimum for 6 marks it will be asking in the exam. These problems it is asked. The first one, this question, the first problem, it is asked for 6 marks in the question paper. If I already shared the question paper, you can refer in that. Next, we will go with a few more problems in a different way. Okay. Next, find the work done in moving a point charge of 5 coulombs in the electric field E, where 4x ax minus 3y ay volts per meter. Here different locations are given. From this, we have to find out what is the work it is going to be done. In the previous case, we already solved how it is going for. Here observe here, the first case here is from 300 to 00, and second in this only it's given from origin to the one more location, that is for 030, that is one thing, and one more is from 300 to 030, x to y, here x to origin, here y to origin, along the straight line path joining the 2 points. This is the question it is given. First you have to consider what is the differential length in the Cartesian coordinate system. The dl is going to be what? Dx into ax plus dy into ay plus dz into az. What is the work done equation? That is w is going to be minus q integration b to a e dot dl. dl is of what? This is the equation we taken. Next, q is a constant, minus q, where integration is varying from b to a. What is the given equation? 4x ax minus 3y ay dot with the dl. That you have to write here. Then that is going to be equals to what? This ax into ax, right? It will be 1. Ax into ay, ax dot ay is 0, ax dot ax is 1. Okay, based on the basic things. But from that I can write the equation as minus q integration b to a 4x dx, I will get minus 3y dy. Ax dot ax is of 1. I am repeating this, and ax with a different element if I am going to multiply ay or else az, it's going to be 0. Okay, then that's going to be equals to minus q, which we are applying the integration for both the function here. Therefore, b to a 4x into dx minus integration b to a 3y into dy. Now we'll consider the case for the first one, where b is varying from from origin to the somewhere 300 to the a point 000. Observe here, b is in the x coordinate 300. It is moving towards the origin, that is, this is the final point, this is the initial point. I hope you remembered when explaining, right? A is 00. This is from this we have moving the point charge towards the origin. Therefore, x is varies to 3 to 0. The equation of the line which is along with the x-axis, y is all values are 0 in the both case, and z is also going to be 0. Therefore, y is 0, z 0, dy is also going to be 0, and dz is also going to be 0. In the first case, where integration b to a 3y dy, this part is going to be 0. Remaining is of what? B to a 4x into dx. W1 is going to be minus q, where it is varying 3 to 0. Observe here the limit where I am taking. This limit I am taking 3 to 0, b to a, 4x into dx. Then go for applying the integration. They will be getting as 4x squared divided by 2, where the limit is 3 to 0. Then we know the charge, that is 5 micro, minus 5 into 10 raised to minus 6. Apply the limit. 0 minus 4 into 9 divided by 2 you will get, that's going to be plus 90 microjoules. This is one problem. In the same way you should go for the second one, where it is varying from y. A is at from origin from 0, 0, 2, it is moving towards the A, that is 0, 3, 0, where y is varying, right? Observe here x and y are x and z are 0, therefore x and z are 0 means exact dx dz also going to be 0. The remaining is of what? And again x is 0 means integration 4x dx is also going to be 0. Therefore w2 is going to be minus q minus of integration 0 to 3y into dy. Observe here it's not from 3 to 0, it is from 0 to 3. Go with the arrow, 0 to 3, 3y into dy. Then go for integration, apply the limit. You will be getting, just go for solving, you will be getting as plus 67.5 microjoules. Therefore what is the total work done for both the case? It's going to be w is going to be w1 plus w2, that's going to be 90 plus 67.5, that's going to be equals to 157.5 microjoules. This is the first case. In the same way we have to find for the second case, where our B and A is in the different locations. Observe here B is at 300, then A is at 030, 030 means as shown in figure, this is how it is located and it is moving from B to A. If I want what is the line integral of this, well, we can use the line equation. So you will be getting as y minus yb, that's going to be equals to ya minus yb divided by xa minus yxb. As you can write to x1 also, you can write x1 minus y1 minus y2 divided by x1 minus x2, that is going to be equals to y minus y2 then divided by x minus x2. You can write basic line equation. You already in the PU classes are in linear equations, you already use of this. Substitute based on this, we can substitute here, then you will be getting as here y is going to be equals to minus x minus 3, that's going to be minus x plus 3. Therefore what is here, dy is going to be what? Minus dx, this is constant, it will be going forward. Therefore w is going to be minus q, where integration is changing from 3 to 0, 4x into dx minus integration y is varying from 0 to 3, 3y into dy. Then it's not needed that telling, it's okay. Then about go with the minus q, 4x square, just integrate here, then apply the limit, then solve for this, you will be getting as plus 157.5 microjoules. This is what this is how you have to solve the problem. Actually this part is not needed, but I just told what. In the same way you have to go with the equation of this I give as a assignment. 4.23 is given as a assignment. In the same way you have to go. Okay, use the equation, it's a simple one, you can do it off. Again 4.23 under 24 is given as assignment, 2 problems, where the same process what we taken the previously, the same things you have to go with, that's it. A small changes are there, just observe those, then you can proceed that. Now we will go with the next different type of problem. Calculate the potential difference VAB for a line charge. Rho L is going to be 5 nanocoulombs per meter on z-axis, where A is given as 2 meters pi by 2 comma 0. Then B is going to be 4 meters pi and 5 meters. This is a given question. From this we can go with writing the diagram how it is going to be. For A point is at 2 meters. I can fix here, it is of 90 degrees. Then the B point here it is at, and it is 4, x is varying from 4. Then it is of pi and about the 5 meters. Means it is of rho, pi and also z. It is of a circular Coulomb system. The charge it is shown. Therefore, for infinite line charge, where it is we don't know, the equation is going to be E is going to be equals to rho L divided by 2 pi epsilon naught times R into AR, where our DL is going to be what? It is varying with respect to, I can write here is sometimes in the books they given as a rho, or else in terms of R they may give. In some of the question paper also it is given as the same. They mentioned as rho, or else in some question paper it is given as R. Both are going to be same. Don't get confused in this. Okay. Then therefore DL is going to be what now? DR into AR. Therefore VAB is going to be, we know that, minus B to A E dot DL. We know this E, that is rho L divided by 2 pi epsilon naught into R into dr, where B is varying from B to RA, means of this part, RB to RE. Therefore that's going to be rho L divided by 2 pi epsilon naught ln R, because 1 by R is integration is going to be ln R. Then the equation is going to be, here it is RB, okay, it's merged. Therefore equation is going to be minus rho L divided by 2 pi epsilon naught ln RA divided by RB. This is what the potential equation we got. This is what the coordinate system is of. Already told that is of a cylindrical coordinate system, where it is rho pi z. If it is coming as theta, then it is going to be a spherical. RA is going to be 2m and RB is going to be 4m. Then VAB is going to be, just you substitute in the equation, then 5 into 10 raised to minus 9 divided by 2 pi. Rho L is nothing but your charge. It's given 2 pi into epsilon naught ln 4 by 2. Use your calci and go for calculation. You will be getting the potential difference as 62.2298. Like these problems, it will be asking for 4 marks. It is simple. When you go see this, it will be somewhat what it may be. Keep in calm and use the equation. It will be easy for you. This is one problem. Next, we'll move on to the next problem. Given a point charge of 200 pi epsilon naught coulombs at C is 3, minus 1 plus 2, a line of charge 40 pi epsilon naught coulombs per meter on the x-axis, and the surface charge is of 8 epsilon naught coulombs per meter square on the plane. Here it is given as x is going to be minus 3, all in the free space. Whatever the point charges are there, it is in the placed in the free point space only. In this, find the potential at P. What is the value here? It is location is given 5, 6, 7. Then if V is going to be 0 at Q 0, 0, 1. This is the given information for us. Based on this, the diagram will be, this is our plane, a surface where it is taken, that is x is of minus 3, and this is our rho s, this is called as rho s. Then a point charge is of, here it is given as 3 minus 1 minus 2, 3 minus 1 minus 2, 1 point is there. Then where is our P location? 5, 6, 7. 5, 6, 7. Somewhere you will get this. Then This is a small surface area that is taken as a ds. The first case, if I am going to consider for the first part of this, the point charge Q1 is going to be 200 pi epsilon naught coulombs at C 3, minus 1 plus 2. Therefore, Vp is going to be what for this? Q1 divided by 4 pi epsilon naught R1 plus C1. In the previously we taken this. C1 is of what? A constant value. The R1 is going to be take of this. Then from the from P to the charge, what it's going to be? 5 minus 3, 6 minus 1, 7 minus 2, right? 5 minus 3 whole square plus 6 minus of minus 1 whole square plus 7 minus 2, that's a whole square. That's R1 is going to be what? Square root of 78, the distance between P and C. Always remember the potential where it is asked. From that point we have to consider the where is our point it is given for us. Within that we have to find what is the distance of in between of those. For that reason you have to take this distance. Then to find a C1 of this point, where V is already given, it is as a 0 volts, where it is given here, right? 0 volts at the Q is of 0, 0, 1, right? Therefore, VQ is going to be what? Q1 divided by 4 pi epsilon naught. R2 is of, observe here, 0, 0, 1. Now, this 0, 0, 1 with respect to this distance. Therefore, 0 minus 3, 0 minus 1, 1 minus 2, right? Therefore, R2 is going to be square root of 0 minus 3 whole square plus 0 minus of minus 1 whole square plus 1 minus 2 whole square. That is going to be square root of 11. We know that VQ is going to be equals to 0. That's going to be, we know Q1 is of 200 pi epsilon naught divided by 4 pi epsilon naught square root of 11 plus C1. From this we can find out what is C1. It will be getting as minus 15.077755. Then Vp is going to be what? Means we have to substitute the C1 in the Vp equation now. Therefore, Vp is going to be 200 pi epsilon naught divided by 4 pi epsilon naught into square root of 78. Epsilon naught is going off minus of 15.0755. That's going to be minus 9.4141 will be getting the value. This is the first case. Next is of what? Due to line charge along the x-axis. Because x is given as minus 3 plane, right? For that reason. Then VPQ. Again from P to Q again. Is going to be along with the line charge. Therefore, rho L divided by 2 pi epsilon. Because of line charge, we have to use as rho L. Rho L divided by 2 pi epsilon naught ln RQ divided by RP. In the previously we find out in the general form, right? From this equation we are using here. There is an interlink. Just you have to remember this. That's it. This is the potential difference equation. Therefore, line charge, it is at the x-axis only. So, you will be getting only value for x only. Therefore, RQ is going to be what? R will be 0, x is there. Therefore, only you will get as 1. This is the distance from the line charge. Therefore, RP is going to be what? 6 square, 6 minus 0, 7 minus 0 of this 6, only 6 to the point is only varying with respect to 3, 0, 0. In that case, you have to take 6 minus 0, then 7 minus 0. You will be getting as where you should not consider here as a x. That's going to be square root of 85. Then substitute in the equation. Therefore, you will be getting the VPQ as minus 44.4265 volts. Therefore, VPQ is what? VP minus VQ, where VQ is going to be 0. Therefore, VP is going to be what? VPQ plus of VQ is going to be minus 44.4265 volts. This is what absolute potential of P. Then the case third is of surface charge in the plane x is going to be 3, x is going to be minus 3, where it is parallel to the yz plane. This is what how shown. Then here a small note, as E due to infinite surface charge is known, use of the equation VAB is going to be minus integration B to A E dot dl. Therefore, E is going to be what? Rho s divided by 2 epsilon naught into Ax, where Ax is a normal to the yz plane. The point P is in front of the plane as x coordinate of P is going to be taken as 5. This is for the plus Ax. Therefore, dl is of what? This equation we know, dx into Ax plus dy into Ay plus dz into Az. Therefore, E dot dl is going to be what? Rho s divided by 2 epsilon naught. Only we will getting as dx only. Remaining will be going to be 0. Therefore, Vpq is going to be, here the integration will change from q to p, rho s divided by 2 epsilon naught into dx, where the potential from p to q, p and q. There xq is going to be 0, and here in this case xp is going to be equals to 5. Therefore, vpq is going to be minus integration 0 to 5 rho s divided by 2 epsilon naught times dx. That's going to be equals to 5 by 2 rho s divided by epsilon naught. The value is going to be minus 5 divided by 2. This rho s is of 8 times epsilon naught divided by epsilon naught. Then we'll be getting as minus 20 volts. This is what the problem. Next, Vpq is going to be Vp minus Vq. Vq is 0. Therefore, Vp is going to be what? The same value, minus 20 volts. Therefore, total Vp is going to be, just you add all the three, then we'll be getting as minus 73.8406 volts. This is how you should go with the problem. And next problem, in the same way it is asked, this 4.27 do as a assignment. Totally 3 problems I given as assignment. You should do the upload. Okay. We'll stop here. We'll continue in the next class.